going to take a look at some examples dealing with dilations. In the first one, I'm actually going to dilate a segment, and I didn't put my segment A or my point A and B in here, so I'll put that. But I'm going to dilate segment AB using C as the center, and I'm going to use R, or sometimes referred to as K, the scale factor of -1/2. Now, to do this, what I need to do is I need to connect my pre-image, and I'm just going to go with point A to C. But what I also have to look at is I notice that my scale factor is a negative, which means the way I think of it is my pre-images are going to be on the other side of the center of rotation. So I'm going to need to make my ray go like this. And now I know that my A prime is going to end up being over here somewhere, and I just have to figure out where's that going to be at. So to do that, I'm going to need to figure out how far is it from C to A. This is where I'm going to use my ruler. So I'm going to measure it, and I could use a compass for this and do a construction, but this is going to be a little bit easier, so I'm going to use that this time. And when we do the dilations, I'm going to say we're just going to use a ruler. Probably won't ask you to do a dilation this in depth, but for here I'm going to show you where everything's coming from. So I see that C is right there. Now that's telling me that from A to C is 2 11/16. So then what I'm going to have to do is I'm going to have to cut that in half because my scale factor is 1/2, or the absolute value of it's 1/2. Half of 2 11/16 would put me at 2 11/32, which I'm not going to be able to do because I don't have 30 seconds on here. But that's going to be close to 1 3/8. So come over here and go, well, let's pick a pretty color like purple. So if I go to 1 3/8, that's going to be approximately right there. So my A prime is going to end up right here. Now I need to do the same thing with my B. Oops, didn't need that. Move my ruler out of the way. I take my straight edge and go through, or start at B, go through C, and then my B prime is going to end up somewhere on the bottom part of that ray. And again, I need to measure how far is it from my center of rotation, or excuse me, dilation, to my pre-image. My pre-image being B this time. And now this one I'm looking at, and this is going to be approximately what do you want to call that? Probably 9/16. 1 9/16. So when we come down here, I have to cut in half because my scale factor is 1/2. That's going to be approximately 3/4, just a little bit more than 3/4, which is going to bring me out to approximately right there. And then call that B prime. So now I can actually make my image here, which is going to be segment A prime, B prime. I'll make it the same color as the rest of the purple stuff. So there we go. So what I've done now is I've dilated segment AB using C as the center, and there will be the image. Now, if it's a true dilation, the scale factor should hold up here as well, where if I take half of that, I'm going to get the length of this. And I could use my ruler, put it on here, and you're going to find out that this one's approximately 2 1/4 inches long, a little bit longer. So half of that's going to be right around 1 1/8. And when we look at that, that's about where I'm at. A little bit more, just like that was a little bit more than 2 1/4. So I've dilated it using my straight edge and my ruler. Now my next one, I'm going to go to the coordinate grid. And I have a triangle, and I give you the coordinates of the triangle, and I want to find the image of this triangle after a dilation that's centered at the origin. So I'm going to point that, focus on that, centered at the origin, which would be right here, and the scale factor is 3. Now notice it's positive scale factor, so that my images are going to be on the same side of the origin as the pre-image. Now you got a couple ways to do this. The first way I'm going to look at it is the straight up graphing it. So I'm going to just go with graphing the point -1, 2. There's point C. Now my scale factor is 3, which is going to tell me I have to be 3 times the distance away from the center. We'll go back here now. I can make my ray. It's got to go through there. It's going to have to be plenty long like this. And now I got to be 3 times the length from purple to blue in my picture. Well, I look at this and I'm going up 2 and over 1, so I'm going to have to go up 2 and over 1 3 times from the origin. So up 2 over 1, and I'm pointing this out on the graph, but you can't see. I suppose I could do this. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I would end up right there. Then let me use, I'm just going to put a blue point there, being that would be my C prime. Now another way to look at it, being I have the origin as the center, I can take my J, which is at 3, -2, and being the scale factor is 3, this isn't the proper notation, but I'm just going to multiply both of those coordinates by 3. And then I'm going to end up with my J prime, which is going to be at 9, -6. Be another way to do this. So if I plot that one, J was at 3, 2, 1, 2, 3. There's 3, -2, excuse me. And then J prime is at 9, -6. And if you go ahead and look at this one, well, notice I went right 3, down 2, right 3, down 2, and right 3, down 2. I'm there. So it worked both ways, whether I kind of think of this as somewhat of a shortcut. All we got to do is multiply by the scale factor, and we're going to get the coordinates of our point, as long as the center of dilation is at the origin. So now you can take your pick on, well, how do you want to figure out where point R is, or R prime, I should say, because R is at 4, 5, and I think I'm going to go with, let's just do a little multiplication. R is at 4, 5. If I multiply that by the scale factor, which is 3, I'm going to end up at 12, 15 for my R prime. So 12, 15 is going to be right here. R prime. This would have been R. Should have labeled these. This was J, and this would be J prime. Now if you go ahead and get your straight edge out and create these triangles, our first one was triangle C, J, R, right there, and then our C prime, J prime, R prime. Oops. And we have our pre-image and our image. Now my next one, now I give you the pre-image and I give you the image, and I want to figure out what is the scale factor. So what do I have to multiply the lengths of the blue quadrilateral by to get to the lengths of the red quadrilateral? Or what would I have to multiply the coordinates of the blue quadrilateral by to get to the red quadrilateral if C were at the origin? Now, we don't know where C's at, so that we can't necessarily do that. We're just going to have to go with lengths of these figures. And what I'm going to do is I'm going to look at this length because I can see that that's 2. And then I'm going to use this length because that one I can see is 4. So I have those two corresponding sides. Now the question is, do I want to look at the scale factor as 4 over 2 or 2 over 4? And sometimes it's easier to come down here and now answer this question first. Is this dilation enlargement or reduction or a congruence transformation? Well, hopefully you can look at this and see that, oh, the blue, going from blue to red, it got bigger. So I'm looking at an enlargement, which then tells me, do I do 2 over 4 over 4 over 2? Well, I'm going to have to put the bigger number in the numerator. So I'm going to have to go with 4 over 2, which gives me a scale factor of 2. So the red is twice as big as the blue, or all the points on the red quadrilateral are twice as far away from the center as the points on the blue. I'm going to use, for the most part, it's pretty much the same figure, but now this time I'm going to go and I put it on the coordinate grid, and I'm going to let C, the center of dilation, be the origin. And I want to figure out the scale factor this way. Now we already know the answer is 2, but I'm going to show you how we can come up with that in a case where we don't know it. I'm going to go to my point E, which I know is at -1, -2. And I have point E prime, which is at -2, -4. Remember, the scale factor is what do I have to multiply essentially these coordinates by? -1, -2. So what am I going to multiply that by to get me to my image, which is at -2, -4. And really, I don't need all of this stuff. I just need part of it. If I just focus on the x's or just the y's, that's going to be enough. So I'm going to look at just -1 and -2, and then what's going to go here. So if I just pull that out, really now my question becomes -1 times what equals -2. Now in this one, this is pretty straightforward. It's pretty easy to see, but sometimes it may not be. So this is where you just maybe throw a variable in here. Call that x. Well, how do I get my x by itself? In this case, I divide by that number that's in front of the x, which is a -1. If I divide both sides by -1, I find out that x equals 2. There was my scale factor. Same thing as it was before, which it should because I'm using the same figure. But the other thing now to notice is, notice these two numbers that I use. The -2 and the -1. Those were the x coordinates at my 2 points. I divided them. I could have taken the y values, the -4 and the -2. If I'd have taken -4 divided by -2, I still would have ended up with 2. So it's another way to find your scale factor, but it only works if the origin is at the center, or excuse me, if the center of dilation is at the origin. And then that's going to conclude my examples dealing with dilations.